So yeah, I'm David Parker. I've been with Novacoast, I think 16, maybe 17 years now. I actually got started with computers when I was 5 or 6 years old. We got the first family Apple IIgs, and shortly after that, I taught myself how to program the computer in BASIC. And fast forward, now I lead the team of professional hackers and who do security assessments at Novacoast. So I'm going to go ahead and share my screen here. Okay, so what is NCAT? You may know Novacoast already, but NCAT is the Novacoast attack team. Again, really, we're a team of professional white hat hackers whose goal is to break in and find the problems before somebody else does. And ultimately, we're not looking to point fingers. We're here to help you fix those issues and, in the end, improve your security posture. So let's back up for a moment and just look at what everyone on the phone is dealing with here. Looking at cybersecurity as a whole, we've got the technology, which really the technology and tools are just one piece of the puzzle. We also have the people who we hope are making quick decisions and are well informed, and we have process that hopefully is repeatable. But as you probably know, these three pieces don't always work as a well-oiled machine, and automation is difficult. So we see, a lot of different size organizations here at Novacoast across many different verticals, and pretty much across the board, we see groups buying different tools from the different vendors, that are supposedly best-of-breed solutions, but there's an issue with that. We also see that it's really hard to attract and retain really good security talent. So, the problem is we see groups mashing all these different technologies together. They don't work well together. They're not integrated. Each tool in itself is pretty complex to implement. And on the people side of things, there's no time to really be strategic. There are mistakes, there are shortcuts, and in the end of that, security posture declines, which is great for my team because one mistake is all we need. And we'll see some examples of that later. And yeah, looking at the breach landscape, the trend here is definitely not slowing down. Over the past couple of years, we're seeing 40–50% hikes year over year in terms of the number of records that are being breached. And this is just about publicly known breaches. The way breach disclosure regulations are built today in the U.S., there are also plenty of breaches that never hit the news. So in the past year, there was $112 billion spent globally on cybersecurity. So why are we still having these problems? Now real quick, let's jump back to one of the poll questions. And I'll give everyone a moment here to answer this question. All right, so the answers are coming in. Tricked a couple of you here, and let's jump back to the slides. We'll address that issue. So the short answer is no. Vulnerability testing and pen testing are not the same thing. And even beyond that, not all pen test groups are created equally. really the two questions to look at when designing out a pen test or a security assessment program are, who do you want to defend against and what are you defending? There's a difference between, are you protecting against a kid working out of his basement, just kind of opportunistically having fun, versus a professional attacker who does this all day long and knows what they're looking for and how to go after and exploit systems, versus a full-blown, let's say, a nation-state attack, or an attack by a very well-funded adversary who has lots of money, lots of time, and very sophisticated techniques. So typically what a lot of groups call a vulnerability test, or what a lot of groups call a penetration test is typically a glorified vulnerability test where they're just really looking at the surface and kind of scratching it, not going very deep, and calling that a pen test. We like to go much deeper because of our technical talent and go through things that are way beyond the surface that no tool would ever see, and dig deep to uncover the underlying issues. So another quick question here. So yeah, maybe you can just reply in the comments. Have you had a penetration test in a lot of depth performed by an outside party in the past 2 years? So looking at the penetration test and security assessment landscape, we like to break it into really 3 pillars. There's the infrastructure, the applications, and the people and policies and kind of surrounding context around the tools. The infrastructure, looking at the external of what can a bad guy do coming from the outside public internet, attacking any publicly available assets, versus the internal side of, if someone's plugged into, let's say, a wall port in a conference room and they have an IP address on the network, what can they get to? Can they see different VLANs? Can they get to confidential data? What risk is possible there? And then wireless is interesting because it kind of blurs that line between external and internal. If I can sit in front of the building, from the parking lot, and get onto the internal network from the outside. If you're familiar with SCADA or industrial control systems, we do a lot of testing there as well. And that's basically, think public utilities, E911 systems, manufacturing, and all these other industrial type processes that are controlled by computer. We're seeing more and more in the cloud. That's always interesting. We'll talk about DDoS later. And then on the application side, this is where we've really had the most interesting findings in the past year or two, because the bad guys are less and less interested in the infrastructure and the network and kind of these boring run-of-the-mill pieces that don't get them much anymore. Where they're really looking for is the data and the users and the things that make you unique as a business. So, myself and most of my team come from a software development background in addition to security, which makes us really good at seeing the applications, seeing the layers of custom integration, the websites, the web apps, the mobile apps, and understanding what's really happening behind the scenes and how to attack that. And then going beyond that, some groups have us also not just pen test the application, but review the source code, look at the blueprints and the architecture, and review line by line to see, are there unsafe API calls? Is input being sanitized properly? Is data being encrypted properly in transit, at rest, and kind of getting more visibility into the application. So a lot of people also ask me, how do I get to become a pen tester? Where do you even start? In terms of methodology, it's kind of a mixed bag. A good pen tester is doing 90% or more of the work manually. Of course, everyone uses some tools and some automated scanners, but that's really the first step. Every day we're navigating a diverse technology stack, and we see a little bit of everything. And that's one of the reasons we approach pen testing as a group, because everyone's kind of a specialist in their own little niche of pen testing or technology, and we combine that to kind of collectively attack all aspects of the organization. Now, for most of the people on the call who are in charge of defending these networks and these environments, I actually feel pretty bad for you guys, because as a defender, you need to protect all of these issues, and as an attacker, we only need one to get us in. So enough of the boring stuff. Let's tell some stories and talk about what we see in the field and go from there. So this was a casino that we recently pen tested, and when we start a pen test, we're basically hired to be curious and not assume that the controls and policies in place are actually effective. We're going to start with nothing and kind of work our way up. And like Hector said, in the 16 or so years I've been here at Novacoast and pen testing, we've always broken in and pulled out something, as you'll see in the stories here. So with this casino, we started with the external, testing the public website and publicly facing assets and remote access. Found some issues there. And then we moved on to the internal phase of the project, where we showed up on site with a few members of the team. We actually set up initially, we kind of walked around the casino floor, picked out this table in front of the cafe, and set up our laptops with wireless. And a couple hours later, we were off doing our thing. No one came up to us, no security guards, no one stopped us, and we were, finding issues right off the bat. Now, there's a lot of money involved at the casino. A lot of groups like that, you would think, are using something like network access control or multiple layers of firewalls or two-factor authentication to protect their critical systems. Turns out the first line of defense for this casino was a piece of tape over this wall port that anyone could have walked up to. So we did that. We found this port, we took off the tape and plugged right in, and that got us on the internal network with a perfectly good IP address. So shortly after that, we found some systems with Heartbleed. There's a whole mess of text coming out of that, but the key is that we found one of the VMware host servers vulnerable to this issue, which allowed us to basically dump raw memory. And we found some ugly stuff in there, one of which was credentials to the VMware host. This was a machine that hadn't been maintained, no one even knew about it, and that got us access, local admin access to the VMware server and all the servers running on that. So then we jumped over to other segments within the casino. We started looking at the gaming environment. Here you can see where we took over slot machines and gaming control systems. This screenshot here is actually a live feed of ATMs and credit card processing transactions here. And then we jumped over to the physical security side of the house. And through a few layers of exploits, we took over the security camera environment. We could have moved them around. We could have turned them off. We were digging through the old archives of recordings and could have deleted those. I won't spend too long on this, but we also looked at their HR pieces and other physical security, found some fun incidents that happened kind of on a daily basis. And again, this was all still from that one spot in the casino where no one ever stopped us. And just to make it worse, we after we had kind of fast forwarded and taken over the casino, all of their IT, all the gaming systems, and Active Directory domain admin, we broke in multiple ways and replicated the same exact attacks from the gym in the hotel. Another story here was a bank that we did an external pen test for. Well, actually, it was external and internal. We started with the external, found some publicly facing web apps. We compromised one of those applications, which in itself was a pretty minor vulnerability, but that got us a little bit deeper. Then, a couple layers deeper beyond that got access to some valid user credentials. Now, we found those user credentials were actual corporate users, and then we discovered the VPN. We used those credentials to log into the VPN, and now we're on the internal network. So even before we started the internal testing phase of the project, we were already inside. And then through that, we again took over Active Directory. We got ADFS, we got admin, and here you can see us one click away from unlocking the doors to the server room or any other secure piece of the building. Actually backing up, we tend to do a lot in healthcare and financials, typically the heavily regulated industries. And we see, everything outside of that as well, but this was a hospital that we, on the internal assessment, we ended up getting access to the medical devices and found a JBoss server that allowed us to run some exploits, deserializing some really ugly malware or ugly payloads, and get remote command execution out of that. So by building this payload and posting it to this website, that basically allowed us to run code. And because Java was running as a local admin on that Windows machine, now we have local admin. To quickly recap, we were testing this hospital. We took over domain admin, and this all started with a development web server. That ultimately got us access to the entire domain from this one machine. And then we got multiple ways to access patient data. This is us watching real people's x-rays in real time, among many other pieces of medical data. We also took over the EPIC electronic medical record system. This is a treasure trove of patient data and lab results and really where the doctors live day to day. And also, if you notice this endpoint antivirus notification on the bottom right, I always love seeing that because that sometimes makes our job a little bit harder, but that never really stops us. We also got access to their SAP systems and all their financials, all kinds of fun stuff. And then this was actually for an e-commerce company. We tested the external and got into one of the servers in their DMZ. Initially, this again started with a web application that we compromised through remote code execution. That allowed us to implant a custom payload to do DNS tunneling to bypass their firewalls. And with that, we tunneled our own private VPN from the internet to their internal environment. So now looking at the inside, we got access to this one server you see here. We didn't know what it was initially, but it turns out this was the fire control system for the entire corporate campus. So we could have triggered the fire alarms, could have disabled it, done some bad things there. This was for an insurance company. Like I said, we're not only trying to tell you about the technical issues, but trying to paint a picture of what the context is around that, and what the impact is of what we find. Along that line, we found executives' diaries and passports and savings account statements. We also broke into an iSCSI backend, which was hosting basically VMs for the entire company. So at that point, we had equivalent to physical access to every one of their servers. We ended up copying a couple of those off the iSCSI, inspecting the file systems, and pulling out all the data. Now we're seeing a lot of IoT, a lot more in the past year, and kind of backing up on the other side of the house at Novacoast, we do a fair amount of IoT development, developing firmware and protocols and mobile applications for IoT devices and companies. And because of that expertise, we're really good at attacking those systems as well. So, anything from door locks to, we saw some security cameras, medical devices have been huge for us. Even things like printers, most of them are running a full-blown Linux stack, and if we can break into that firmware, we've got an unprotected node on the network. So one of those examples was a door lock manufacturer targeting consumers, and this group is really a physical security company. They were coming out with their first mobile-enabled, Wi-Fi, Bluetooth door lock, and came to us and said, we're not cybersecurity people, we're not really software people. Can we hand you this device and go at it and see what you can do? So we found all kinds of issues with that. We looked at the firmware, we looked at how the firmware communicated with the mobile app over the air, and how all that talked to the backends on the internet. We found some issues with data not being encrypted on the wire, and some of the data was actually encrypted. Things like the packet telling the lock to, or the door to unlock. That was pretty well encrypted. And we weren't able to crack that and decrypt that data, but we did find that we could man in the middle and capture that packet and then go replay it as many times as we wanted, anytime in the future. So even though we couldn't read the data, we could tell the door to unlock anytime we wanted. We also have been seeing a lot more around DDoS. And DDoS is less about security and answering the question of how do we break in. It's more around operationally, how worried are we about downtime being directly tied to revenue, a loss in revenue or bad publicity. So to test that, years ago we took some of our R&D efforts and things we were kind of working on behind the scenes and developed a weaponized automation platform that we kind of retooled for doing DDoS and built this worldwide NCAT botnet. And so now this is built very specifically, and we can code it to target specific websites or applications, even specific form fields at the layer 7 piece, kind of going beyond just let's take a bunch of bandwidth and throw it at an IP address and see what sticks. So we did this for a stock exchange, one of the top stock exchanges, and found some interesting things. before the systems themselves started falling over, some pieces behind the scenes had issues before they hit their theoretical bandwidth limit. The biggest issue was the SIM and the SOC and the logging and monitoring and visibility tools couldn't handle that amount of traffic and that amount of events. So even though the websites were still functioning, the SOC team had no visibility, no ability to diagnose or ultimately contain the situation. We also did this for a couple banks that were pretty identical in terms of infrastructure, but one had a head start by a couple of years in terms of testing their DDoS maturity. And with the same kind of scope and the same technology stack, the second bank had some pretty big issues because this was the first time testing DDoS. Now, let's switch over to a quick question. Can anyone guess what it cost to take down this bank's entire internet presence, including their online banking? Okay, we got some responses back. It actually took 5 cents to bring down everything, and even crazier, this all took a matter of seconds to take down their entire internet presence. So we don't have time for too many more stories, but yeah, again, it's always a matter of not if we'll get in, but how and how long will it take. And so taking a step back, kind of an aside here, what does that mean in terms of incident response, and what do we do with this information? Again, we like to tell our customers the goal is not prevention. We'll always get in. So the focus really should be on detection and visibility and containment. Of course, you want to cover some of the really easy pieces to prevent, but beyond a certain point, that becomes a waste of time. And looking at incident response in the industry now, it's pretty well matured. There's good regulations, there's pretty well built out standards and policies, and we've kind of figured out how to do that, as an industry. But the one piece that's really missing in almost all groups we see is measurement. And this is really kind of a topic for another day. We'll actually do a future webinar on this, but something to start thinking about is how do you put metrics on your IR and your ability to measure the entire security program. So let's jump back to pen testing and what should you get at the end of this type of an effort. Ultimately, again, our goal is not just listing out technologies and vulnerabilities and dropping a report on your desk. It's more about assigning risk and prioritizing and clearly communicating what needs to be solved tomorrow versus a year from now, and helping you through that process of improvement. So we like to present things in an executive format where, if we're testing the same group 2 years in a row, we'll highlight, here's where you were last year and here's where you are now. Here's the trend and some bullet points into why that happened. We also typically break that into the external environment versus the internal. For some groups, that's more on a business unit basis, or even by physical location. But yeah, however it makes sense to report that and chop up the data, we're flexible to do that. And then we give an overall risk score, because a lot of times what we see is the external environment is hardened on the outside, but once we're inside, it's soft and gooey. And then the most important piece of that is the recommendations. And we break that into the short-term tactical pieces versus the long-term strategy. The short-term tactical is more about how do we close these specific holes and deal with quick remediation items. The long-term strategic pieces are taking a step back and understanding how do we, instead of being reactive, how do we build controls or improve gaps in security posture to build out the next couple of years of security roadmap. And finally, we like to highlight things that made our job more difficult. Again, not to point fingers, but give a complete view of where you sit in terms of risk. If there were things that slowed us down or prevented us from breaking in, we definitely want to call those out as well. So I think we have a few minutes. I'd like to switch over and do a quick walkthrough of a sample report just to see more detail of what you would get there. So of course, this is a fictitious client name and the sensitive data is all redacted, but at least you can get a feel for how the report's built out. Again, it's broken into the executive summary and the technical report, where the executive piece is just a couple pages of very high-level information. Here's what we did, here's the organization's risk, a quick explanation into why, and the top few tactical fixes and the top few strategic recommendations. Then the bulk of the report is in the technical section, where in some cases this is even triple digit, because we're going into a ton of detail around what we saw and what we did and every step along the way and what that ultimately led to. I don't have time to go through too much here, but I'll at least cover, we run the initial discovery, we do some scans, we find kind of the really obvious surface vulnerabilities, also including websites and applications, covering OAuth's top 10 items, ways to bypass authentication, SQL injections, cross-site scripting, all that good stuff. But this is where we really draw the line between vulnerability testing versus penetration testing. And this is where we're spending 90% of the time actually attacking live systems by hand and combining multiple layers of exploits to get to something larger. One good example of that here is this was a government organization that had a publicly facing website. And with that, we found putting some strange characters into the search field, we got this nice error page. And this was interesting for a few reasons. One is we got a small snippet of source code, just enough to understand what was happening behind the scenes. So now we know it's talking to a database. We also got the full path on the file system to that code. And we noticed the versions of .NET and ASP and IIS were pretty outdated. So this was a bunch of huge red flags, and we got the whole team looking at this and attacking by hand. Turns out that search box had a SQL injection where we were, from the public internet, able to run direct SQL queries against the internal database. So now we're able to list out the users, tell you which ones are admins, and it turns out we had access to, there were about 100 other databases on that same server beyond what the application was talking to. So in terms of the technical detail, we're giving the full payload and all the raw data, so you can go back and prove it to your developers, and also retest it once the issue's been fixed. But again, kind of highlighting this in terms of business impact, we want to be able to show this to a C-level executive or a manager and someone who may not be technical, but still have them understand why this matters. So here again, from the public internet, we're able to download social security numbers, dates of birth for everyone in the company, redacting that, of course, but just showing that that really is possible and how easy it is. And then we pivoted to the HR databases, this time pulling out full socials, not just the last 4 digits, and everyone's salary in the company. So that's always, the kinds of things we're looking for. And again, security cameras, being able to shut those off or delete the tapes. And then finally, the recommendations, again, broken into short-term versus long-term. The only difference here is there's more detail so that these are actionable recommendations, and the full list, not just the top few from the executive summary. So looking at what an engagement would look like, typically there are a few different tiers of types of projects, looking at the scope and the time involved and the amount of complexity. And one thing I want to highlight here is we typically have a remediation window where once we have the report, we've done the testing, we build the report, we set up a time to walk through the report in more detail with you and really explain the findings. And from that moment, you have some time to go attack the low-hanging fruit and remediate some of those items. And then at the end of that window, we come back, recheck those same vulnerabilities and verify, if your remediation was actually effective. So yeah, in short, doing pen testing and security assessments and really going deep on the technology is really good insurance. Best case scenario is we find nothing, which never has happened, but if that does happen, you at least have the peace of mind. And more likely, we'll come back with issues you may not have even known about or systems you didn't know were in your environment. And we can be the ones to find it before somebody else does.